Welcome to SOC Minute Weekly, where we break down the cybersecurity stories that mattered most this week and what they mean for defenders.
This week, the common thread is trust. Who can issue identity, pass through a gateway, reuse a cloud credential, publish code, or quietly inherit instructions inside an AI workflow?
We will follow that thread from stolen access to active exploitation, industrial systems, software supply chains, endpoint control, and finally AI on both sides of the SOC. Let's start at the center of a Windows domain. CVE 2026-54121 may allow a standard domain user to abuse an enterprise certificate authority and impersonate a domain controller. That moves the risk from certificate administration into Tier 0 territory.
An enterprise CA already participates in a foundational trust relationship. If its permissions or enrollment behavior can be abused, the blast radius is domain control rather than isolated certificate cleanup.
I initially thought the main task would be patch verification, but PKI activity also needs investigation. Find every enterprise CA and review unusual enrollment, issuance, configuration changes, and rights assignments involving domain controllers.
Then connect those events to authentication and privilege changes. PKI logs are often collected without being treated as first-class detection data, which is dangerous when the CA is trusted to vouch for the domain.
That same trust problem appears at the network edge. Citrix patched 2 NetScaler issues, including an authentication bypass affecting certain FIPS and NDCPP builds on gateway and AAA servers. The build qualifier matters. This isn't every deployment.
An authentication bypass may remove the failed login pattern defenders normally expect at the front door. Confirm whether those certified builds exist and validate remediation against Citrix guidance.
So, did a session appear behind the gateway without the usual identity trail? Compare appliance access, AAA activity, identity provider records, and downstream sessions for gaps or impossible sequences.
Those logs may live in different systems, making correlation incomplete. Patching comes first, but recent access review determines whether this remains vulnerability work or becomes an investigation.
From gateway trust, the next step is delegated access. Suspected Russian espionage clusters are abusing legitimate Google OAuth flows and WhatsApp linking to hijacked accounts, sometimes leaving no malware trail for endpoint tools to find.
That is what makes the technique uncomfortable. OAuth consent and device linking are normal features. The useful distinction is whether the workflow fits the user's history and whether account behavior changes afterward.
Review who approved a new grant or link, when it happened, the session context, and subsequent access. A new relationship on a high-value account deserves validation rather than automatic escalation.
Attribution remains qualified, but the defensive problem is concrete. A legitimate authorization flow can produce successful account access while endpoint alerts stay quiet.
And some access outlives the original mistake. Researchers found more than 9,300 AWS access keys still active after exposure between August 2022 and August 2026, long after a repository or script may have been forgotten.
Active doesn't prove abuse, and permissions vary. But even narrow keys may enumerate resources or read data, while broadly privileged credentials create a much larger foothold.
Disable or rotate exposed keys, then review cloud audit logs for unfamiliar sources, enumeration, new identities, policy changes, and access outside the key's normal pattern.
Rotation closes the current door. It doesn't reveal who may already have walked through it, or whether another access route was added.
That persistence gives context to the next story. A threat actor claims to hold 3.6 million employee records taken from Azure environments associated with several major companies, allegedly through compromised credentials.
The scale sounds alarming, but the word claims must do real work here. The record count, company scope, and access path aren't independently confirmed by the supplied material.
Organizations with plausible exposure should review successful sign-ins, new device or enrollment activity, unusual access to employee data stores, and accounts touching unfamiliar assets.
Location alone is weak because VPNs, travel, and service activity create noise. Compare each identity against its normal behavior and determine whether access progressed into data collection or persistence.
This connects to the previous story through the potential consequence, large-scale data exposure, while the level of certainty is different. CareCloud confirmed a breach affecting more than 3.7 million patients.
What stands out to me is how long that harm can last. Healthcare data is unusually durable. Unlike a password, it can't simply be reissued, even though the disclosure doesn't confirm the initial access path or every exposed field.
Map integrations, service accounts, data exchanges, and applications touching patient records. Preserve access history long enough to determine what was viewed or exported, not merely who logged in.
The long-term risk includes targeted fraud and social engineering after the technical path is closed. That consequence can outlast the immediate response by years.
Now we move from stolen or abused access to software under active attack. A Windows IKE service extensions flaw can lead to remote code execution without user interaction, but its exposure is narrower than a typical endpoint vulnerability.
That distinction matters. IKE supports IPsec and VPN-related use cases, so defenders need to identify where the service runs and which systems are reachable, not simply count every Windows endpoint.
Review deployment scope, patch status, and network or endpoint anomalies around those hosts. Waiting for an alert literally labeled IK exploit may leave the real activity invisible.
The source doesn't establish the victim set or a universal indicator trail. Exposure plus active exploitation is the warning. Useful logging determines whether an attempt can be reconstructed.
The second Windows story moves from remote exposure to a familiar local process. CISA says ransomware groups are actively exploiting a task host vulnerability, but alerting on every task host event would create noise immediately.
The stronger signal is sequence, unusual parent-child relationships, command lines, follow-on processes, or network activity beside credential access, remote execution, or rapid file changes.
Patch validation starts with affected asset inventory. Patched somewhere isn't useful when the team can't identify which Windows systems actually received the update.
And the reporting doesn't provide a complete exploit chain or victim scope. Active exploitation raises urgency without giving analysts permission to label normal task host behavior as ransomware.
The same exploitation pressure extends beyond Windows. Zimbra CVE 2026-73570, an OS command injection flaw, is now in CISA's Known Exploited Vulnerabilities catalog.
Command injection can turn the application into a path for running commands on the underlying server, although the supplied reporting doesn't establish one complete post-compromise chain.
Locate affected Zimbra systems and correlate unusual requests with host-child processes, outbound connections, and unauthorized access. Timing matters more than a suspicious command viewed alone.
CISA's entry creates a remediation obligation for covered federal agencies and a strong urgency signal for everyone else. Older collaboration servers shouldn't disappear from the SOC inventory. And the inventory problem gets harder with AI infrastructure. CISA says a critical MLflow vulnerability is under active exploitation, while some instances may sit inside project environments, never registered through the normal asset process.
And this isn't merely an unfamiliar web service. MLflow participates in model development workflows, so compromise may affect the integrity or reliability of work moving through the environment.
Ask engineering where every instance runs, then review exposure, access logs, configuration changes, and network traffic. A new experiment can be normal. Unexplained access to the service is different.
The available details don't define what attackers did in each case. Active exploitation means exposure validation can't wait for a perfect indicator set.
That concern about specialized platforms leads into engineering environments. Siemens Parasolid has a high-severity out-of-bounds read while parsing XT files, with possible code execution before fixed versions. This is not a confirmed exploitation case.
The exposure depends on workflow. Which engineering systems import models from suppliers, customers, contractors, or shared repositories? A crafted file matters only when it reaches the vulnerable parser.
Start with product and version inventory, then prioritize systems receiving external files. Detection may rely on unusual child processes, network connections, or crashes around applications handling XT content.
There isn't a clean exploit signature in the supplied material. Patching is the clear control. Telemetry may only reveal the strange aftermath if a malicious model was processed. The next Siemens story moves closer to physical operations. Agencies are warning about active threats targeting S7 PLCs with AI-assisted exploitation scripts. AI-generated may simply mean the exploit is easier to adapt and troubleshoot.
The operational consequence can still be serious because these controllers may sit close to physical processes, but the warning doesn't establish which environments were breached or that a safety event occurred.
Identify every S7 asset and determine whether the SOC can see connections and unusual commands reaching it. Many organizations know their IT estate far better than traffic crossing into control space.
If industrial telemetry is thin, defenders may see abnormal connections or controller behavior without being able to prove AI involvement. Investigate the behavior. Don't overpromise attribution to the script generator.
Engineering data is also the target in the Clop campaign. The group reportedly built a Java web shell specifically for PTC Windchill and FlexPLM, with functions to decrypt credentials, enumerate files, and support targeted theft.
I wouldn't treat this as a web shell cleanup. If credentials were recovered, investigators still need to determine whether they were reused through legitimate application access after the original implant was removed.
Find every deployment, then correlate unusual commands, file browsing, authentication, and outbound transfers. Normal use can involve many files and service accounts, so volume alone won't settle the case.
The useful signal is the combination of application anomalies, credential-related behavior, and unexpected movement of design data. Persistence or credential reuse must still be proven locally.
From targeted platforms, we shift to legitimate infrastructure repurposed by attackers. Evo1bot turns internet-facing Linux routers into SOC 5 relays, making the router an exit point for activity aimed somewhere else.
That complicates attribution. Suspicious traffic from an IP address may reflect a compromised gateway forwarding another actor's connections, not the network owner initiating them.
What surprised me is how often edge device telemetry remains thinner than endpoint coverage. Verify the router inventory and look for relay-like behavior or outbound patterns unrelated to its role.
The source doesn't establish specific models or an infection path. Mirai-derived signatures may help, but unexplained SOC 5 behavior from a gateway is the stronger reason to investigate.
StopAndProtect shows the same borrowed infrastructure idea at a larger scale. Nearly 2,000 compromised WordPress sites, distributed malware, and in some cases, stored stolen documents, screenshots, and activity logs.
Exactly. The victim site becomes working attacker infrastructure rather than a one-time redirect. Removing one malicious file may not address the broader role of the host.
Review unexpected uploads, modified files, malware delivery behavior, unfamiliar access paths, and outbound traffic that doesn't match the site's purpose. Legitimate WordPress sites also host documents, so context matters.
The campaign is global. but the reporting doesn't say every compromised site performs the same function. With that much infrastructure, static block lists will also age quickly. The trust problem then moves into the build process. A compromised maintainer account for the Rust Crate array ref allowed malicious code to run an Infostealer during compilation, turning routine development into the execution point.
That blurs into normal developer activity. Compilers spawn processes, touch source trees, and sometimes reach the network. Start by identifying the affected versions actually pulled and compiled.
Use lock files, caches, registry records, CI artifacts, and workstation telemetry to scope exposure. Referencing the crate isn't the same as executing the malicious release.
And don't focus only on laptops. If a build runner compiled it, the credentials and tokens available in CI may be more valuable than anything on a developer's browser. And Rust wasn't the only ecosystem affected. 14 Trojanized NPM packages posing as calendar and streak utilities delivered Red C2 4.0, a Linux backdoor that creates a path from module loading to native process execution.
The AI-powered label is less useful than the host behavior unless the vendor explains which functions use AI. Why is a node module directory changing permissions and launching a binary?
Review package inventories, install and load events, executable permission changes, child process lineage, and network traffic on Linux build or application systems.
A package can exist without running. The correlation from module load to executable creation and process activity distinguishes downloaded exposure from actual execution.
The next pair moves from shared infrastructure to direct endpoint control. SilkParasite targeted Central Asian government bodies with 7 remote access tools, 5 previously undocumented, making any single malware signature a weak detection strategy.
7 tools sounds sophisticated, but novelty alone doesn't prove sophistication. Researchers may simply not have published them before. Either way, behavior gives defenders the more durable lead.
Look for new external connections, persistence, remote control, and sensitive access that doesn't fit the endpoint's role. One odd connection is thin evidence in an environment with legitimate remote administration.
The combination matters. Unfamiliar network activity followed by unexpected processes or access to sensitive material. The reporting doesn't explain why the group uses several implants, so we shouldn't invent that strategy.
Infostealer reaches the same endpoint control objective through social engineering. On macOS, click-fix-style delivery reportedly gives the operator a live view and remote control of the victim's browser.
The part that concerns me is the continuity of the session. By interacting with the existing browser instead of merely stealing cookies, an attacker may inherit the same device and authenticated context.
Correlate browser activity with unusual processes, remote control behavior, and authentication events the user can't explain. The service may see a familiar session while the human behind it has changed.
That familiar context can weaken new device or impossible travel detections. The report doesn't prove every authentication control is bypassed, but it shows why macOS browser control needs endpoint visibility beyond login telemetry.
That brings us to AI as an attack surface itself. In a controlled simulation, malicious instructions spread among 6 coding agents through editable persistent prompt files, what the researchers call AI mind viruses.
The label is dramatic, but the underlying issue is clear. Mutable instructions trusted as working context can become a propagation surface between agents.
I haven't thought of prompt state as a supply chain boundary. Where do those files live? Which identities or agents can edit them? And are changes attributable?
This was a simulation, not evidence of broad production exploitation. Still, file integrity plus agent-to-agent activity may reveal unexpected tool use or the same malicious instruction appearing across several agents.
The defensive side of that equation is Wazoo's integration of AI for repetitive work and pattern discovery. It could reduce queue pressure, but a confident summary cannot become a new source of truth.
The goal is to accelerate analyst decisions, not replace investigation. Analysts still need the underlying events, the relationships the system inferred, and a way to challenge the conclusion.
Would deployment actually improve triage quality? Compare alert volume, prioritization, and sampled outcomes before and after enabling the features, instead of measuring speed alone.
A faster wrong decision is still wrong. Useful AI assistants must preserve raw telemetry, auditability, and clear analyst authority over the final call.
This week's stories followed trust as it moved across certificate authorities, gateways, cloud credentials, exposed services, engineering platforms, shared infrastructure, browsers, and persistent AI instructions.
The practical lesson is to choose one high-value trust boundary and verify ownership, patch status, logging, and whether recent use can actually be reconstructed. Collection alone isn't investigative visibility.
And when AI appears in the headline, separate the label from the behavior. Exploitation, process lineage, delegated access, and evidence still matter more than the marketing term.
That's it for this edition of SOC Minute Weekly. Thanks for listening. Stay safe, stay informed, stay secure, and we'll see you next week.